The depths of space hold many mysteries, and around 12 years ago, astronomers stumbled across a new one. A single strong flash of radio light that lasted for just a few milliseconds. This cosmological signal was named a fast radio burst, or FRB for short, and whatever had produced it must have been exceptionally energetic. What is impressive is that FRBs are not rare. In fact, hundreds of them have now been discovered. Astronomers are still debating what the most likely source of these signals could be, and it's quite possible that nature has created something we have never before imagined.
One of the problems that we have is that we often only know the positions of FRBs very approximately. To get to the bottom of this astrophysical mystery, we need to pinpoint the locations of FRBs very precisely, and to do that, we need to use a very large and sensitive radio telescope.
Because astronomers cannot build a radio telescope big enough, they use multiple telescopes across the globe to observe at exactly the same time. This technique, known as Very Long Baseline Interferometry, or VLBI, effectively turns all the individual telescopes into one big one.
In 2017, we used the most sensitive VLBI array in the world, the European VLBI network, to study an interesting FRB, which appeared to repeat in an unpredictable way. This enabled us to localize the FRB to a dwarf galaxy in a region where the stars are formed.
Since then, astronomers have localized 3 more FRBs, but none have been observed repeating. These FRBs were all found in massive galaxies, radically different locations from the first known repeating FRB. This raised the question whether there is a fundamental difference between FRBs that have been observed repeating and those that have not.
With only one localized repeating FRB, it was difficult to draw conclusions about them. But now we've had the opportunity to study a second repeating FRB. We observed the FRB with 8 EVN telescopes across the globe and conducted follow-up optical observations with the Gemini North Telescope in Hawaii.
The astronomers collected terabytes of data and observed 4 bursts of the FRB. They found that this repeating FRB was in a star-forming region of a relatively nearby spiral galaxy, whose properties are similar to those of our own Milky Way.
The location of this FRB is radically different from the previously located repeating FRB that was found in a comparatively puny dwarf galaxy, but also different from all previously studied FRBs. Does this diversity mean that different types of sources can produce FRBs?
Or is it possible to devise a single model to explain the different host environments?
By finding FRBs in a diverse set of galaxy types, now including galaxies similar to our own, astronomers are again scratching their heads. However, the relative proximity of this new FRB, which is only 500 million light-years away, is a unique opportunity to study these phenomena, and hopefully finally unveil what these mysterious signals are from the depths of space.